Okay, so this second half of today is about a work, sort of like a project workshop. Okay, so every one of you, in fact, if we have time, I do actually want to double back to the 10 students from last class as well, because last class we just talked about sort of like, you know, data and what you want to do. But this is more like a workshop. It's as if you're presenting to me and I'm your supervisor, and I would say, okay, well, fine, this is your progress, but what you want to do and how you want to formulate this problem and so forth. Okay, so the first person to go up is Kanok-wan, right? So let me stop share and let Kanok-wan have the screen. นะเราใช้เวลาทุกหารไปเลย40 คนเพราะว่าเราเผื่อจะเอาอีก10 คนขึ้นมาด้วยเพราะฉะนั้นโอเคใช่ไหม40 คนนั่นเองโดยประมาณใช่ครับ Okay, so not that much time. So shoot. Excellent. Okay, Kap. And me being fairly senile, you have to make the font big. Good. Start your project. What's your project area? Okay.
So my project will be about customer personality analysis, and the data set I use will compose of characteristics of customers and their background and what specific product they bought, and then I will do the analysis like visualization, statistical analysis, unsupervised learning, and data mining to find like a pattern or trends that the ideal customer of that specific product.
Okay, very good. Yeah. Okay, and so where are we? So let's see your data set. Yeah, the more you show me in class, the more I, your TA, and your friends can help, right? So this is very clear what you want to do. Fine. So let's see what sort of data set, what kind of visualization you have in mind.
Okay, let me.
Oh, you have the screen. Okay, sorry. Okay, so for example, now you guys have that page, right? That where's that page?
Could you see my screen, like the data set?
Not yet.
Okay.
Now, what I'm going to do is a little bit of a cataloging mode, right? So while you are showing me this, I'm going to do a little bit of function catalogs. In other words, sort of like, you know, what you intend to use. So, you know, remember the mathematical reference page, right? There's a big section on visualization and graphics, right? So for example, you might want to say, okay, just open up this page. Let me show you in the line. So for example, you can go to here, right? And you can say, okay, so the visualization tools that you plan to play with.
We cannot see the screen right now.
Can you? No, not yet. I can't see either. Oh, okay. Now I see. ID, year of birth, right? Education, single, income, kids home, teen home.
Yeah, and
now again, you remember what I said last hour about your data? You have to say, how is this generated? Okay. Who are these guys? Where do you get this data? Is it something from your company? Maybe you have a company. So what data set is this?
Pardon?
You have to tell us a little bit. Remember the last hour that I mentioned when you talk about your data? How is it originated? Who created this data set? How do you source it? Is it from your company? Is it from Keiko?
Yeah, this is from Kaggle.
Okay, this is from Keiko. Okay, and Keiko is going to say, where is this generated from? So who are we talking about? American consumer in the Midwest? What?
It didn't say in the source, like where it's from.
The what?
Like it didn't mention where this data is from.
It doesn't say?
Yeah.
Oh, that's quite odd. Okay. And okay, method 10. Well, because of the field, there's so many, very few field. This is it. Is this all?
Yes.
Now, ID is just a data item, right? How many customer are we talking? How long is this data set? Number of rows?
185.
Oh. And what's kid home, teen home, and wine? What's that?
Kid home is the number of kids at home, and teen is the number of teen in the family, and MNCY is the amount they spend with wine's product. Like that spending.
Oh, okay. And you're just trying to find. Now, this strikes me as, even though a very small data set, it strikes me as something with an X and Y structure to it, right? For example, column B, C, D, E, F, G could be your explanatory variable to predict H, the amount of wines. So even though you mentioned in your project that it's unsupervised learning, I was kind of guessing that the intention of this data set was to predict amount of wine. I don't know, maybe. It's up to you. It's up to you. I mean, if you really insist that B, C, D, E, F, G, H are still sort of like attributes that you want to just do cluster, that's fine. But perhaps there's more to it. There's a way of predicting H from B, C, D, E, F, G, right? But this is a very small data set. It's not, doesn't look all that interesting. But anyway, if you can, certainly, I wouldn't just make it unsupervised learning. I would literally make it a regression problem out of it if you can. Okay. Now that means that you have to encode B, C, D, E, F, G into numbers. Okay. So those are different techniques, right? So you have to describe things like, okay, what is it? What's the year of birth? Year of birth, what kind of field? Let me ask you just like a pop quiz. Okay. What number scale does year of birth belong to?
Number of kids.
Okay. Well, you have to think about this because I would expect you to describe the data. I would have to see an evidence of good thinking about your data set, especially if the smaller the problem. In this case, you only have 100 items, and you only have 8 columns. The more you have to give me some analysis, right? Right? You can't just say, okay, this is the data, I'm just going to cluster it. That's just not going to be. That's going to be like a homework as opposed to a class project. Okay, so put a little bit more thought. But okay, but you're on your way. You got a good start. Okay,ครับ. The next person would be Nathamon, right?
Hello,ค่ะ.
Okay, so one, can you give your screen to your friend?
Can I share my screen?
Where are you? เห็นยังจ๊ะ
Can I share my screen?
Yes, please. You
Okay.
have to. Okay, very good.
Okay,ค่ะ. My project is about the food supplement. Like this is my data.
Supplement as in
Food supplement and I,
food. Okay,
yeah,
gotcha.
food supplement and I got the data from the Kaggle.
Okay,
This
go.
is my data. Okay.
Okay, fine.
And I start this project with the objective that I want to find out that why the food supplement industry in Thailand has a very high growth rate within a few years, which nutrition that brought them then, and what are the differences between each brands in the market.
Mm-hmm.
So I starting to categorize them by the nutrition, and I go first with the question that is the overall rating from the people or from the customer is correlated with the price. So I found out that the overall rating from the customer is quite high, is around 9, but the price per serving of each food supplement is really cheap. So my next goal is I want to find out that which are the category of the nutrition of them that receive the high rating but still in the low price.
Okay. Now, first, let me just make a quick comment. You know that histogram is very good at giving you the picture of the distribution, right? What it's not giving you is the picture of how two variables go together or not, right? So for that, something that you seem to be touching on, I would imagine that correlation plot would make more sense, or scatter plot, right?
Yeah, okay.
Okay, so I would suggest maybe try, just list plot, right? See if there's an obvious pattern. Maybe people just want to spend less, and so they okay. And this is something that you would do visually, and if it turns out that if it turns out that it's very obvious, it's almost like a straight line, for example, then the problem is trivial. If it's not, then maybe you have to start to build the model, and that's the objective of the exercise. Can you flash back to the data columns again?
Yes.
Right. So number of overall rating, price, product. Right. Okay. Improve. Okay. Now. Okay. Protein crunch bar. How are you going to deal with? Well, first of all, I, J, K, and L, what are those? What kind of number scale would they fit?
Pardon?
What kind of number scale? Remember, I told you I'm going to ask you number scale for everybody. What kind of number scale does product category belong to? Column I.
Oh, okay.
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 What number scale?
I'm not sure.
Come on. You did the homework, you did the exam.
The number scale.
Nominal, right?
Oh, okay.
It's just a name, right?
Oh.
Right? Or is there something to it? Like, for example, there's amino acid and there's amino acid plus or something like that. But it looks to me like a nominal scale thing, right?
Yes.
Okay. How about overall rating? What kind of number scale is that?
The number, the integer or something.
Okay, let me say it right now. If you cannot answer what the number scale your data belong to, you will fail this class. Okay.
Okay. I will work on index more.
Okay, that's like lecture 1. Okay,
Oh,
so these are all different. Data. How many entries do you have? How many rows?
of the overall data, right?
Yes.
Um, 12 row.
No, that's columns.
Yeah, 12 column. This is my data.
Yeah. How many rows?
In this data is a 14 row and 840 columns.
Okay. Well, your data it just happened to be that listed on the side, but actually from our perspective, right? We're talking about the tabular data. The canonical form, the standard form is the dimension go to the right, right? So that's 14 columns and 840 rows.
Okay.
Okay. So in your Excel, it goes all the way down to 840. Fine. Okay. Now the reason I don't like small data set is because you really have to use as much data as you can, and if you want to test data, you have to block out sort of like testing data. But anyway, okay. So what is your objective here?
For this data, right?
Your objective, yeah. What do you want to do? Do you want to make?
I want to know that if I want to create this business in the future with the nutrition that I want to use, like what are the nutrition that I will receive the overall high rating from the customer within a lower price to create the successful business in the future.
So it's so what do you have to build? You have to build a prediction model.
Yes, I want to.
At a very top level, you have to be able to say, supervised, unsupervised, prediction, classification. This thing should be something that you're thinking about for the first time. You have to be able to say right away, what do I want to do? I want to predict price from factor. Then, based on that, I want to maybe choose the minimum quality to get the right price. I don't know. What exactly do you want to do, right? What kind of data set do you plan to do? Okay, fine. What kind of analysis you want to do? Statistics, fine. What do you want to achieve? My expectation is explore and understand the advantage and disadvantage of each ingredient and develop many food supplement. Okay, so translate your fourth topic, okay, into a technical statement. What do you want to do? You want to predict? You want to classify? You want to, sometimes you don't want to, you want to create a prediction model, and then the question is not about prediction. The question is about whether or not factor X is a good predictor, right? So when I say that your objective is to build a prediction model, it doesn't necessarily mean you want to predict something. If I have A, B, C, and I can predict D, right? I make a prediction problem. D is a function of A, B, and C. But the analysis may be something like, in terms of influencing D, does A matter more or B matter more or C matter more, or in which direction, right? So you're creating a prediction model, but your objective is not to predict. Your objective is to account for which factor matters the most, right? So tell me what you want to do. Okay, so let's we have to sort of like keep the speed rolling, got the signal. So you understand what I mean?
Yes.
It's good that you make the statement, but turn it, it should be something like paragraph in English, one sentence in English, and then, ultimately it comes down to a function, all right? So you have to make it more technical as you go on. So you want to predict, you want to create a prediction model, and based on that prediction model, I want to assess the impact of individual variable. So maybe you use column B, C, D, E, F, and G to predict column H, and you want to see, in order to predict column H, what matters most? Is it column B, column C, right? You can do that as well, okay? We haven't talked about that in terms of statistical significance, okay? Maybe we'll make a note to add that in the lecture, okay? And there are plenty of things that I haven't covered. So be more precise about what you want to do, okay? Okay. Very good, Kat. So that makes you, where are you there?
Okay,ค่ะ. Thank you.
ค่ะ good luck ค่ะธัญนันท์
Hello
ธัญ
ค่ะ
ญานันท์
Hello ค่ะ
โอเคค่ะ
I'm gonna share my screen.
good, very good, huh?
So this is my data set. My data set has about 29,000 rows, and with initially it has 3 columns. So it has like the member number, the date of the transaction, and the item description. But the 4th column is what I compute by myself. So like I see that this data set, it ends around like the end of 2015. So I kind of like see like how many days in the last, like the date of the last days in the transaction.
So this customer on the 15th of March 2015 bought 4 things, right?
Yes.
Okay, so this is very much a classical basket analysis, correct?
Yeah.
Okay, good. Where are you getting this data set?
From Kaggle, but it didn't say like where exactly it comes
That's
from.
fine. Okay.
Yeah. And what I plan to do is I plan to do a customer segmentation based on it's called RFM analysis. So basically it's like see like how recently they have bought,
Good.
how frequently, and the other factor is normally they use like a monetary value of the transaction, but by my data set I don't have like the monetary value. So I think that I will use like how many items they bought in that transaction instead. Yeah, and like from this 3 factor, I'm gonna like find like which customer segment is like the one that is like a loyal customer, like they bought a lot, they came here frequently, or which customer segment is like the segment that the supermarket should focus on more, like they haven't bought for a long time, but they usually bought a lot, things like that. And I also want to find like if these 3 factors kind of like have a correlation, like if this customer buy frequently, does that means that in each transaction, like they only bought like a few items, things like that. And yeah, because like I also have like the item, like the name of the item in each transaction. So I think that once I find the customer segment that is like really good to the supermarket, I want to find like a association rule. So like maybe they can like do marketing strategies, something like that. Yeah.
Okay. This is very good. Let me make a. Okay, I see what you're trying to do. I want all your friends to pay attention. First of all, this is a classic basket analysis data, right? Basket analysis data. So in terms of data mining, like old school data mining, this is a perfect test case for it. Okay, test case for it. Now, you mentioned that you want to analyze along the axis of recency, frequency, and monetary value. How should I say this? You actually have a richer data and information than the analysis. In other words, RFM is a very crude way of categorizing your customer. Okay, I just want to give you this background that in fact the reason RFM is so popular is because most people don't have that much data, right? They only have customer ID, time of purchase, and amount. Now, let me ask you this. Okay, you don't have all the information, but let's say you own this grocery store. My question is, do you actually have more or less information than IFM that needed to do IFM? You actually have more. Okay, here you don't know what the price of the sausage and the whole milk is, but the fact that you knew this person bought sausage and whole milk means you actually knew what the person bought, right? So chances are the monetary value is something that's already in your database. It's not here, but it's in your database, right? So my comment, first of all, is that RFM is actually not something you wish to do. RFM is often the only thing you can do because your grocery doesn't record anything except who bought it, when, and how much. Whereas here, you actually have a deep dive information, right? So RFM, again, it's not your ambition. You should say, oh, great, I have all this basket data. Let's do RFM. No, RFM is sort of like, I don't know anything. I just want to know if they shop a lot and buys a lot. Okay? Do you understand that? Okay. So with that comment in mind, I would encourage you to literally go through the full data mining exercise, association mining, maybe association rule, okay? So there are 4 things, right? What products go with what products, right? That's what like frequent item set, okay? And then you separate into conditional. If you have yogurt and milk, are you likely to have canned beer as well? Okay, so it's not just frequency of item set, but it's probability of B given A and C, let's say. Okay. And then you have 2 things now you can analyze, right? The frequency of things appearing together and the probability of B things appear given A things appear. Okay, so you have 2 analyses already. Then you have 2 more analyses by stretching this across time. So you have basket analysis over a given period, like in a month. Or you can have something like conditional, given that the person bought sausage in week, early in March, is he likely to buy it later on? Okay, so it's sequential in time. Okay, so you actually have 4 problems in a very classic data mining thing. I would encourage you to try as much as you can along that side. Now, to go back to RFM, okay, because you obviously think it's nice, but literally it's the least you can do. Okay, fine, let's do that. Let's do that. So you can say, well, we have 3 axes. We have recency, we have frequency, and we have say number of items. So you can do something like, now, what can you do? Normally, again, RFM, not only is it the least you can do, it's also the objective. In other words, there's something you like about most recent. So you like most recent. You like more frequent. You like more monetary value. Usually in a problem, this would be all you have as a target. So you may actually have something else as a variable, as X. So in other words, you can think of this as 3 Ys. You have 3 Ys. And you want to predict recency or something like that. And you want to say, what kind of person, male, female, college educated, or live in this zone or live in that zone, who really maximize the recency, the frequency, and the monetary value. Okay, so 2 comments. RFM is usually the least information set you have, and it's also an objective. So you tend to have to gather some other information to predict this. So in real life, what you would have is you would cross this data set, member number, with something else. Now, when the person becomes a member, the member 1,000, chances are you would have the address, you would have the, age, sex, whatever. Okay, that would be your problem. So RFM is only interesting, A, because that's all you got, or B, because that's your target. Okay. Now, as a variable in itself, what can you do? The only thing I can say you can do is clustering. Now, clustering in high dimension, you have to do dimensionality reduction. We talked about that. But in this case, what you can do, you can just plot in 3 dimensions all the data points, right? Recency, frequency, and number of items. Okay, and literally you can use your eyeball to cluster. Okay, but you can pass that through cluster analysis algorithm as well. So yes, you can use RFM as the variable to do cluster analysis. May or may not be that interesting, but yes, you can do that. But I would imagine that now that you have this category of item, you should do the proper data mining basket analysis. Okay. Okay. So you have more information than RFM, and you don't have the input, the member characteristic to make RFM prediction. So you can't do much really with RFM except with this classification, so clustering. Okay.
So you
Yeah, but
think
RFM is very popular because it's intuitive. But you know, if somebody tried to sell me a software that perform RFM, I would just leave.
So you think
Okay,
it's better for me? Oh, so you think it's better for me to go fully into like that data mining, right?
I would imagine so, because again, you have information. Okay, it's a lot richer. Think about it. Two person on the same day buying $100 worth of grocery versus 2 persons on the same day, one buying salty snack, canned beer, and miscellaneous beverage. The other person buy whole milk and vegetable and vitamins. You have more information. This is a richer information set than just how much. Okay, very good. Okay, excellent.
Thank you.
So let's move on. How are we doing on time? Am I going to cover everyone today? Sorry,นัดช่วยดูเวลาหน่อยนะพี่ก็กลัวบางทีพี่ก็เผลอ
Hi ครับอาจารย์
สวัสดีครับ You have to slow.
Okay, so here's the data set. This data set seems quite popular. I see many people choose this one. So basically it is the customer personality, specifically the wine buyer's personality. So there, as you can see, there are a lot of columns which represent many type of data. So the first thing that I plan to do, and I already did, is basically let me start with my objective. I will try to do the customer segmentation using the K-means algorithm. I'll try to like divide the customers into tiers like platinum, gold, silver, bronze, so I can like come up with the promotion that can enhance the competitiveness of the company, also generate more revenue for the this wine company. So the first thing I did is finding the missing value. So all the missing values came from only from the income columns. So what I did is just eliminate all the column that has missing values. I think there are like around 23 rows. In total, there are around 2,200 rows of data. So there are 93 rows that has missing values. So I'll eliminate all of them. And the next thing is try to find the outliers. So initially there are only the year of birth column, there wasn't an age column. So what I did for me to be easier to like do all the analysis, so I'll just use 2021 this year's and divide subtracted by the year of birth to get that age. So it would be a lot of easy for me to look at the data. So and as a result, there are like couples of people that has the age over 100 years old, which seems
okay. Let me interrupt you real quick.
Yes.
And this is a pop quiz. Year of birth. What kind of number scale is that?
Is it not nominal, not ratio. Is it scale?
Huh? It's interval.
Oh yes,
It's interval because you have difference in years, very well defined.
yes.
It's not ratio because you don't have absolute zero, right?
Yes.
Because 0 in Christian year and 0 in Buddhist year and 0 in the history of the earth year is very different. So, but when you take the present day and you convert it to age, now what kind of number you have? What kind of number scale do you have? Now you have a ratio scale.
Oh yeah.
Because you do have absolute 0.
Right?
Yes. Okay, so very good. Okay, go on.
So I just eliminated all the data that has like the outliers, like people has the age over 100 or people that has very young age. So I eliminated all of those. The next topic that I did is about the preparing the data, just like the age. There are, as you can see, there are kids home and teens home, which represent the children that the customers have. So I just combine them to the kids. So it will be a lot easier for me to do. And the next thing is like the spending. Initially, there were a lot columns saying about the.
By the way,
yes.
I perfectly agree with you. You should subtract the year of birth from whatever 2020 to get the normal days. I'm not sure about combining the kids because I think the reason, my guess, the reason they specifically collect 2 different data sets, sorry, two different numbers, is because the person doing the data collection already have in mind that this matters. If you think about it, we're talking about, say, American household, right?
Yes.
When your children, you have a young children, they're easy to manage, right? So you don't hit the bottom. But once they become teenager, boy, it's a lot of headache.
Oh, yeah.
So maybe they think that, number one, say number of kids, it's not that. It's number of kids versus number of teenager, right? So maybe it's worth it for you to keep them separate. Don't consolidate your data unless you have to, right?
Sure.
In the old days, you have to because your computer is so tiny, okay?
Yes.
But you don't live in that world anymore, okay? So don't arbitrarily get rid of dimensions unless you have to.
Yes, sure.
Okay. I would imagine this, you can literally do an analysis that tests whether or not all else being the same, all else being equal, are you more likely to drink if your children is at a teenage years? Okay, so maybe as your children become teenagers, then you hit the bottles. That could happen. Okay, go on. Next.
Yeah, so the next thing is all the product. I just combine them because they're separated into specific product that customer bought. So I'll just combine all the spending to have just a specific spending. Okay,
same thing. Okay,
yeah.
It may or may not be a good idea. Okay. Eventually, what I tend to do, by the way, what I would do in a proper project is, given that computer does everything for you, you're not tired, you don't have to do the hand computation, you maybe try both of them, right? And see whether or not the individual types of products is a good determination. Now, I haven't really spent a lot of time, maybe next class I should, talking about variable importance. But that is something, once you build it, you can go back and say, does this variable matter? Okay, so it could be something that you can explore. But go on, sorry.
Should I like do like two separated analysis? Like the first one is about in general spending, comparing like the age and the spending, and the next one is go in specifically into each product. Yes.
You don't know what's going to happen. It may be that combining is better because it generalizes better. But if you have separate, it just will like overfit. Okay. So when I say that, don't combine them, I don't mean absolutely don't combine them. Just say, don't combine them unless you need to. But if you're curious about whether or not there is any value to keeping them separate, do both, right? My guess, here's my guess, okay? This is completely unsubstantiated. If you compare two models, the in-sample with more variable will do better. But the out-sample performance, the testing, the one that combines may do a little bit better. That's just my guess, okay? You don't know until you try.
Yes.
Okay, good. Go on.
Okay, so and the next thing I also plan like to maybe divide all the age into like the age group, maybe to like the middle age adult and to like over 60 to find like into like find a specific group and all the data correlate to these groups. And the next thing is about the Marshall status. There are quite a lot of Marshall status here, like single, together, divorce, widow. So I think I'm gonna group them into just single and partner. Yeah, I don't. Is this a good?
Make it a binary. Fine.
Yes.
Yeah.
So yeah. So the next
again, same comment. You know, maybe people who have girlfriends are in a happy mood, but once they get married, maybe.
Oh yeah, probably. Yes. Okay.
So yeah.
Okay, so the next thing is about the data analysis. So I will like compare all the data that I have, like the age and the spending and the kids and the spending, like and their status and the spending, and then visualize it to see like trends and stuffs. Yes, and the last thing would be like I'll do the cluster using the k-means algorithm. Yeah, basically that's my plan.
You know, this is a good opportunity for you to do both say unsupervised clustering to see you know where they are, and supervised learning to predict, right?
Yes.
So you can do that with both of them. Yeah, good, very good.
Yes.
It is from what, Kaggle again?
Yes, from Kaggle, right?
Okay. Okay. ต่อขวัญ
ทอขวัญค่ะ สวัสดีค่ะ
Sorry, made you sound like a boy. ต่อขวัญค่ะ
That's fine ค่ะ Okay, I will share my screen. Okay. Oh, okay, this one. My project is to predict the electricity bill for the next month for user to reduce all maintenance costs.
Okay.
Yes, it's my data. First, I use this data, but it's from like just only one household, but like for each month of their usage. And then I thought that, all right, it's had other like I don't know, other like เขาเรียกว่าอะไร ทุกคน
In your house?
sorry like other แบบมีตัวแปรอื่น I don't know what to say. Sorry for that. So
Yeah,
I download this data.
Okay. Now, I don't know if I'm too quick to say this, but I think there's a problem with this, a little bit of this logic, because the amount of electricity really is just a usage, right? Go back to the previous one.
This one?
Yeah. So, you know, you can't really do prediction because the amount charged is a well-defined function, right? In other words, you don't need to do any kind of machine learning unless you just want to predict. Let's say the electricity authority doesn't give you it's not transparent. Okay, it's not transparent. Doesn't give you how the bill is charged. So you want to model column D as a function of column B or something like that. Okay, but you can see why it doesn't really make sense, because well, it is a tariff, it's a tax, it is a charge, it is a fee. There is actually a fee structure, right? If you know kilowatts hour, you know how much you pay. And so it doesn't really matter how many children live in that house. Okay, you can have hundreds of children, you don't turn on air conditioner. You have one person, you turn on a lot of air conditioner. The point is, you already have all the information you need in column B, kilowatt hours. Okay. Maybe there's a difference in terms of average kilowatt hour and you know, actual daytime, nighttime. But you can see what I mean. This problem would be interesting if you're trying to reverse engineer the electricity charge, right? But no country in the world allows electricity authority to charge without publishing the fee schedule, right? So if you go to the website of Electricity Authority of Bangkok, of Thailand, and Municipal Electricity Authority, they will tell you how much per kilowatt hours for daytime use and nighttime use, and you can literally just multiply. You see what I mean? So if every morning you go look at your electric meter from say morning to evening, and you count how many kilowatt hour you use during the day, and then you add another number during the night, and you multiply by whatever schedule. This is not a data analytics problem per se. You see what I mean? So I'm trying to say now, if you have a population of people living in Bangkok, and forget about the function from kilowatt hours to amount of bills, and you just want to say, can we predict kilowatt hour per person? Now that would be interesting. Okay, you can even say, you know, that condominium is a very efficient way of putting people together, because people who live in a condominium per person, per capita per person, use less electricity, less kilowatt hour per person than people who live in a house. You know, something like that. Something like that. So predicting energy demand is very interesting. But from energy demand or energy usage or electricity usage to amount of bill, that should be, you know, you see what I mean?
Yes.
So it's not per se, I don't see a data analytics problem yet.
Like I want to compare each household usage of aircon, like it's in the future, like from this data.
Okay, let's look at the second data set. Maybe it's more interesting. Number of people, household area, average monthly income, amount paid. Okay, so in fact, everything I said before applies, except the last column doesn't have to be amount paid. It could be like kilowatt hour. Okay, but fine, you can say that kilowatt hours and amount paid are positively correlated. So we don't distinguish between, say, day rate and night rate. You know that, right? There's a difference between electricity charge during the day and during the night. But let's say it's a constant. Yeah, then you divide that by how much per kilowatt hour from its electricity usage. So how come you have this information on amount paid, but you don't have kilowatt hour?
Not sure. I'm download from Kakao.
Oh, okay, fine. So we can do that. So we can, in this case, you can say that amount paid is an approximation of electricity usage, like a proxy. It's not a proxy. It stands in for electricity, and so you can say who uses more. Yeah, then this would be a very good problem again. And then you can do like your friend previously, both unsupervised, where people clustering, and supervised learning, making the last column as your target. Okay, a lot of this will have this feature in common, where you have the first 20 columns, you can do unsupervised learning, and then you can add the 21st column as your Y and do supervised learning. Okay, a lot of them will look like that. Yeah, good. Now, remind me to talk about scaling a little bit, but okay. นัดเดี๋ยวเราพูดเรื่อง scale เรื่อง scaling data เลยนิดหน่อยนะจะได้ไม่ลืม
Okay.
สองเรื่องนะที่ต้องพูดscaling data อันหนึ่งแล้วก็ variable importance นะครับ
Variable important.
เอาไม่หน่อยอาจจะเอาพวก Shapley diagram มาดูโอเคครับ very good so that means you are top one and
thank you ค่ะ
ค่ะสุกเกษมครับ
Yes ครับOkay. So what I want to do is I am the one who doing Thai text and natural language processing. So I want to classify the text that like normally you write in the like you're tracking your money, your income, your expense, classifying into type and income and expense in food, like food, healthcare, utilities, something like that. So this is what my data is. So my data is the text and type of the like the lecture, the income, spending, and price of the text that is a given. So
okay this is just your own thing, right? You generated this.
It's a generated data.
So in this case, again, recall what I said earlier about what you are providing, right? So you can imagine that all the previous project is a combination of quote unquote scientific, discovering relationship and practical applying to whatever. Okay, whereas for you, in this case, it's more like the engineering problem, right? You're trying to create a tool that basically turns column A into column B.
Yes.
Right. So you're not trying to find out any particular pattern or predict what this person is going to do next month or what's going to happen to his income, right? You're trying to create some kind of tools that basically looks at the Thai text on the left-hand side and the amount, and then just generate. Okay, good. Now, this is something, again, if it uses Thai language, you would definitely have to work with probably like a Thai NLP library. So you have to use Python for this.
Yeah. So last week, Peanut and I have a Zoom call and like we test the Thai NPL that use the function. But yeah. So when I test it, I have some problems in running the code, so I cannot like import some data set. So Peanut tell me about like the new one. It's this one. Peanut also told me like if you cannot like obviously cannot use that one, use this one. So I'm trying to figure out what is the wrong of this, because like it's only on the version. So I try to run without the version like in the back, and now I'm trying to like understand how to convert the Thai text into like the actual data that can be like.
Okay. I think from looking at your data set, I think your problem is early on. In other words, you're having problem with the just the tokenizer, because my guess is from looking at, it's a very simple sentence structure. Somebody gives you money, somebody takes you money, blah blah blah, right? So it's not complex in terms of semantics. You're not reading a paragraph. Okay? You're not reading a journal entry and end up with classifying, okay, this is the day you made money or not. So it's a very, very specific sentence. So my guess is if you get the tokenizer right, the fact that you start with the word mommy gave money, okay, this should not have ambiguity in terms of context, right? It should be very simple from left to right. Left does something to right, mommy gave money, or somebody took money. So as long as you get the tokenizer correct, So I would imagine, try to test your tokenizer first. If your tokenizer can separate numerical amount, okay, your tokenizer can identify if it's a baht amount, okay. This should be relatively straightforward, and I would imagine that it's almost trivial to say whether or not it's an income or expense. It might be more interesting to have different types of income, like income from friends, okay. So the way it's
the expense
written,
part is like different, like there are food expense, healthcare expense, and utility expense.
Now, let me say something. It does look, okay, by the way, okay, imagine that you don't have machine learning. Okay, imagine, okay, let's go back 10 years ago. You don't have NLP. You don't have NLP. You could conceivably do what you wanted to do with tokenizer alone. Because once you can tokenize, you can categorize something like this. You can say income action word include ซื้อ, oh sorry, that's out spending, right? Spending, that there's a spending category and there's receiving category, and you can literally do pattern match, right? So you don't need machine intelligence. You just find the word ซื้อ, and that immediately say, you see what I mean? So you can have you can have one word set that say this corresponds to spending or expenditure, this corresponds to income, and you can have another word set that say this has to do with healthcare, this has to do with utility, and literally you can pattern match. So I would imagine that the critical success of your project here is not the machine learning part, it's just the tokenizer. Okay, so once you get that working, it should be okay. In fact, I would imagine that you can literally do this without machine learning. You can literally just have a word set, right? Because you see the word ซื้อ, you know, spending.
Another part is like
word,
if you have enough the data, like database about the word and the category.
Yeah, exactly. So pay a lot of attention on getting the right tokenizer and dictionary. I think there are ready-made dictionary of Thai words that's, you know, pre-labeled. So, you know, it would say something like cocoa is a drink, cafe is a drink, that sort of thing. Okay, so I don't know if you have that kind of corpus. I think I'm sure if you go to Thai NLP, somebody has done something like this. Good, it's interesting. Okay. But again, you have to ask Pinat, because, you know, once you go to Python, I'm very clumsy. Okay, very good. Okay, next. Shawit, yeah. Shawit.
ครับอาจารย์
ครับผม Okay ครับ you have the floor.
โอเคครับ so let me share the screen. So I found the data set of like FIFA soccer player rating and like all the data including the wage and the rate.
Oh, you got the wage. That's good, because last time I think you mentioned you don't have the wage or something. Wow. Okay.
Yeah, so I'm like trying to find the coordination between like the wage, the value overall, and potential. Yeah, and if I have time, I might also find like more about the stats behind. But I'll basically do it like five main thing, which is like age, overall potential, value, and weight.
Okay. Another thing, if I may suggest, I think what happened is this as well. If you're doing in what's called stationary environment, meaning this is sort of like static environment, right? Then I think that makes already perfect sense. But there's also another thing. The fact that markets for player has been going up. Okay. So you can almost say that somebody who signed for the same amount of quality, same amount of contribution, somebody who just signed 2020 contract might get a bigger number than 2015, just because it's a late signing. You see what I mean? Because there's like an inflation in the so maybe the time of contract might be something you want to look at. Or you can do both. You can say, okay, let's look at this binary or static point of view, and then introduce the kind of contract, see if it makes a difference.
I'll find the data because I found this data from Kaggle, but then in Kaggle they recite the data from like another FIFA website where it include all the stat weight and data like from every year inside of there. So I could do that.
Yeah. That happens, by the way. You go to data source and then you go to the data source. That's very good. That's what I like to see. Okay. So you're not looking at this as, this is a homework. I have this data set. I'm just gonna do it. You actually say, oh, where's the source? And you go to the source of the source. That is very good. I like to see that. Okay. This is good. Okay. So you might be able to come up with some kind of quote unquote arbitrage. Like this guy is definitely overpaid, and you can do your own fantasy league.
Yeah,
so literally you can build a model that you can play fantasy league of with this budget I would put this guy and that guy, and then you can win the fantasy league football or something. Hey, why not? Okay, so that's good. So it's like how many players in your database here?
I think this one is like 18,000.
Wow.
18,000.
Holy cow. Okay, good. Now, there's another problem. I'm not asking you to do, by the way. Everybody has important, and there was a team project from your previous class that look at this sort of thing. And I did mention this, so I'm going to tell you as well. Sometimes the optimal design of a team is not just collective performance, right? But it's how they fit together. So you can imagine that, you two-person equally good, but instead of having both of them, you have somebody who's not as good, but one of them is a left striker, the other one is a right striker, or something like that. This kind of complementary, this kind of network or team synergy effect. That's a very interesting model to build. Okay, but for now, just go with individual. Okay, but that's like pricing individual player. But you can imagine that think of the movie like Moneyball or something like that. Where they think about the overall team effect. Okay, so you don't need to have a big batter. Okay, you just need somebody who get people on base, and you have enough of them, and you keep driving the innings. Okay, something like that. So, but that's just I just want to mention that. But what you're doing, I think, is already very interesting. Okay, good. What's work rate? There's a thing called work rate. That's interesting. Okay. I'm not sure if you have the same database as the previous class, but the previous class that was trying to do this kind of project also have like a playing style. I don't know if you have that.
I'll check up. I don't think I do.
Okay, I don't know where it got, but also very good, like aggressive or Brazilian or physical or that sort of thing.
I got those like stats, but I don't have like playing stats. Oh, I have the stats, like the shooting stat or something like that too.
Okay, but not star, right? Like this guy likes to dribble, or this guy like a long shot.
No, not star.
Okay, but already this is an interesting project. Good. Okay, let's move on to Pawaran. Pawaran. Pawaran no show. Okay. Akrit. Akrit.
I'm here, Kap.
Can say your name.
Here's my data, Kap.
Okay, Kap.
It's
So
from
you
Kaggle.
download. Okay.
Yes. It have 9,000 row and 7 column. It's it include date, open, high, low, close, adjusted close, and volume. So I'm thinking about doing a unsupervised clustering and doing like maybe a k-mean and principal component analysis.
Good. Okay, so let me see what you got started. Oops. Why does it look like this? Oh, okay. It's different scale, isn't it, right? Because open, high, low, these are all pricing data. Volume is amount. So certainly we talk about different scales. So you might want to show how you scale the data and so forth. So this is all you got so far, right? Okay.
Yes.
So how would your unsupervised learning look? For example, what would you do? What would you try to do? You try to cluster data into different periods, like periods of, I don't know, very high, very low opening, or different between open, high, low, something like that?
Yes, kind of like that, like the, what do you call it, like sideways movement with a little volatility and then like a upward movement, which imply like where the trend will go, something like that.
Okay, and you have data set from when to when, 1985 to okay. So if you were saying that you may look at period of high volatility and so forth, in which case you cannot have volatility information from this alone, correct? You have to some kind of aggregate. For example, if you just have daily opening, high, close, you may have to say, okay, let's chop them up into weeks. And then you can say that standard deviation of price movement in a given week, right? Because if you have daily price, you can't have volatility of that day.
Yes.
Right? So because in some market, in some data set, they actually give you that, by the way. They can say that on a given day, on the 9th of October 2020, intraday volatility is this much. Okay, but this data doesn't look like it. It only has the beginning, the end, and whatever happens during the day, it doesn't tell you. Okay, so the interesting pattern of ups and down cannot be captured in one day. It has to be across, say, a week or a month. You can say that you can have a rolling window of month. Now, when I say rolling window of 1 month, it doesn't mean you go this month and you go to the next month. You can actually have 1 month, add 1 day, delete 1 day, add 1 day, delete 1 day, right? You can have a rolling window. But the point is, for you to have a more interesting statistics, has to do with, oh, it's an increasing market, it is a volatile market, it is a quiet market. You have to work with a lower frequency than the data. Okay, you have a daily frequency, but you don't have intraday information. So the only way you can do that kind of statistical characterization is to go to a lower frequency. Then you can derive statistics for that lower frequency using the daily data. Okay, so it could be like monthly or bi-weekly or whatever. Okay, so it could be interesting. It could be interesting. Yep. Okay, cap. So you have volume. Okay, good. Okay, so let me know how that goes. We go to Nanapat Song ka? Nanapat Song.
ได้ค่ะ
สวัสดีค่ะ
ให้ share screen นะคะ
ครับผม
ค่ะ so the data I select is COVID-19 and healthy diets.
Good. This is interesting.
Yeah, so my project area is this, and because I want to predict the possible rate of death from COVID-19 associated from the diet. Yeah, and actually the data set that I selected is protein intakes within
Where is this from?
Gaggles.
Oh, good.
I'll share the link later.
Okay. Have you looked at the sort of the paper I shared that about the COVID data that my kid was doing? But that's using our data, so it has a more like a economic thingy. Okay, but this is good. This is good. I really like this. I mean, I wish I had this data set, or I wish I ran into this data set for something else. Okay. So okay. Yeah, send me a link to this. I'm quite interested to look at it myself. Okay. In the meantime, let me show you.
Okay.
So here you obviously have a very clear intention to make a prediction problem, correct?
Yeah, and actually there are 5 data sets in total, but I selected the protein supply data due to the big impact that the protein affect our health.
Okay.
As the least protein intakes the people does, it associates with the obesity and the confirmed rate and death in COVID-19.
Sorry, go back. Okay, so the yellow are sort of like your target, or how am I looking? What is the significance of your highlights? Why the yellows?
I selected the eggs because eggs is like a fundamental and a basic of every food in many countries. So I selected.
Okay. And then you're using eggs and obesity, right?
Yeah.
To
Actually,
explain what? Okay, basically just tell me your X. Tell me your X and tell me your Y. Tell me your explanatory variables and your
actually it is an amount of protein.
amount of protein. But fish also give you protein, right? Fish and meat.
Yeah, but not every country that have eat fish in regular basis. Some country and in their area is not like they didn't in the like they didn't eat so much.
The data is missing, or they don't eat meat.
I think the eggs is the basics of every country menus and recipe that they
I know,
eat.
I understand. Yeah. But you're talking about protein, right?
Yeah.
So there's no reason why fish and meat do not count as protein.
Oh, okay.
Correct? So the only reason, yeah, you know, you may, hold on, oil crops. Go to the top. I can't see the top. Right. Yeah, fish here, meat, right? Milk, even offals. These are all protein source. So I don't think, you know, you don't want to just focus on the eggs, right?
Yeah.
Now you can say something like eggs and fish belong to the same groups, whereas cereal and belongs to something else. So now what can you do? What can you do? Okay, now this is an interesting thing to mention. You have factors, okay? Factors, but they kind of like belong to subcategories. So factors, all here are things you eat. But some of these are closely related because they represent protein. Some of them are closely related because they represent carbohydrate. Some of them are closely related because they represent essential minerals. So what can you do? Okay. Now, I would definitely not, okay, just ignore fish and meat and just say egg is my protein. Definitely, I would not do that. Okay. What might be more interesting is, okay, well, first of all, you can run all this as your input variable. Okay. Again, you're not doing hand computation. So there's no reason why you have to work with just one column when you have 20 columns. Okay. You're not doing this by hand, right? Okay. So there's no problem. What you might want to do if you have more interest into separating protein versus not is you can say, well, you can separate into the protein groups and the vegetable groups and the carbohydrate and the essential mineral groups. Okay. Once you separate them, you can do a few things. Okay. The easiest thing you can do, okay, is just, well, if the number are similar, you can just add them all, right? Egg plus fish plus meat plus mushroom, okay, equal to protein, right? Right? Or alternatively, you can literally create principal component from those. Okay, so you see what I mean? Okay.
Yeah.
So number one, you can throw in everything. Number two, you can throw in protein versus carbohydrate versus vegetables, right? And you can just add the components together, okay? Or create some kind of index. Or you can just use principal component to break down so you can say the principal component variable representing all the proteins. This is a principal component variable representing all the vegetables. You can do that as well. But if principal component is a little bit obscure or requires a little bit further explanation, well, what's wrong with adding all the protein together, adding all the vegetable together, adding all the carbohydrate together, and just running them as you know, again, you have rich data. Why just throw everything else and keep eggs? I mean, I would like you, I just asked you to send me index to this data set because it's very, it has a lot of detailed information. And you already have that. Why would you throw everything and just keep eggs? Okay, I wouldn't. It may turn out that you throw everything in and egg is the most important variable. Fine. But that's what the model tells you, not you tell the model. Okay? This is very important. You are fundamentally doing data science. Okay? To tell the problem, this matters, it's not science. Science, you say, these are the things that could matter. Which one matters? Okay? So don't just say, oh, okay, I don't like fish, I like eggs. No, don't do that. Okay? Don't do that. Send me the link. This looks good. I'll send you the link to, excuse me. Okay, what's your name? Sorry. This is, you are Nantapat Sawant, correct?
Yeah.
Okay. Okay, Kap. Very good. Very good. Doing well. Doing well. Okay.
Thank you.
Rajanan, Kap. Rajanan. Okay, you're up.
Can you see my screen?
Star type classification, NASA. Good.
Right.
Okay, go.
So the source of my data is from Kaggle, and it's actually extracted from NASA. And the data set is for star type classification analysis. And it can also be used for type prediction. And this data set is actually contains like 241 entries, rows, and 7 columns. Here's the data set.
Temperature, relative luminosity, relative radius, absolute magnitude. These are stars, right? Not, okay.
Right.
Okay, good. So
yeah, I plan to do a star system classification analysis and type prediction along with a certain extent of cluster analysis if possible. And what I plan to do is actually analyze each relation among the columns and ultimately develop a machine learning model from it. And what I want to clarify one more thing about the SMAS, which is actually of the spectral class. It's provided in here of SMAS, which is about asteroid spectral type, and it's actually introduced by American astronomers, and the acronym for it is Small Main Belt Asteroid Spectroscopic Survey, which is one of the analysis which I plan to do. And going back to, yep.
Okay, this is very good and interesting, but let me say something, and it may sound like I'm disencouraging comment. Okay, you have to understand, what are we trying to do? We are literally trying to do data science. What does it mean? Data science means you're trying to get information about relationship between things based on data. Yeah, based on data. Data science usually comes in because you don't have better science. Okay, remember the comment I mentioned to your friend who was trying to do the electricity price. Okay, the reason I told that your friend that this is not a data analytics or data science project, to predict electricity bill from kilowatt hours, is because you have a better science. In fact, you have something better than science. You have mathematics. The mathematics is the equation for calculating electricity bills from kilowatt hours and time of usage. So that is the real truth. It's the mathematical function of how electricity bill is calculated. Okay. Now, second up, the highest level of truth in our realm is mathematics. Second higher up is science. Okay. It's only when you don't have science that you use machine learning. Okay, or it's only when calculating using scientific principle is too difficult that you use data science. Okay, so if I'm firing a rocket, okay, and I know initial velocity, I know all this variable, and I know a differential equation that describe the trajectory of the rocket. Am I going to use data science to predict where the rocket's going to land? No, right? Because Newton already gave you a nice equation to plug in, right? Likewise, star mass classification, all this, first of all, is based on science. Secondly, it's also based not only on science, but based on scientific community making the classification scheme, right? So because they are scientists, are they going to hide how they make the judgment? They won't, right? The criteria for star classification is going to be transparent. It's going to be in a NASA document somewhere. So when Neil deGrasse Tyson said Pluto is not a planet, he said, well, Pluto is not a planet because according to scientific community, a planet has certain criteria: size, threshold, relative motion, how rounded it is, because if it's big, it's round. If it's small, it can have irregular shape like an asteroid, okay? So all this is already decided. So for you to download this, I think, if I may say so, you would not add anything by, say, using A, B, C, D, E to predict G, because that will probably be documented. You see what I mean? So the classification, again, it's not auto unsupervised classification. It's scientific criteria. you can literally look at a new star or an old star, take all the measurement, you can fill in the temperature, relative luminosity, relative radius, absolute blah, 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 into a NASA database, right? And based on that, literally, okay, either find that star or that star that's nearest to that characteristic. And that one will have already classification. So I would imagine that what you can do to make this an interesting project is to think of it not as discovery or as kind of predicting star type, but as some kind of tools, maybe to visualize or to look up. For example, you can imagine that based on this, I just look up the nearest neighbor to this new star. Okay, and so it's like prediction, except you don't have to do any prediction. You just say that if a star has temperature of around 2500 kelvins and relative luminosity of 0.001, then relative radius of 0.1, then it's closest to row 7, and that is a type 7. Sorry, the star only has a few types. Type 3. You see what I mean?
Right.
So maybe clustering would be interesting. Clustering, visualization, certainly, right? Some kind of tools to look up tools and say, well, or you know, you don't have to do clustering. You can say, well, if I know the type, how about this? How about I visualize the different distribution of temperature, of relative luminosity, of relative radius per type of star, right?
Mm-hmm.
So you can say type O has this distribution of temperature, right? And do sort of like a manipulate or interactive visualization, okay? So this would be wonderful. This would be something I would love to see, you know? Okay, I see. Oh, and now you can use it. It will be something that helps elucidate what NASA's criteria is all about. Oh, I can see why this is a type 7 or type 5 because it has high luminosity or low temperature or something like that. But basically, you don't want to do anything that science is well defined, because science is already well defined that, in fact, from looking at this, an astronomer can even tell you how this star was born and what original mass. You can say that, you know, there's no way a supergiant would have this initial condition. If it had this number, it definitely is going to end up as a white dwarf. And I can tell you with relative certainty, it will happen in 1.7 billion years because it's at this age. It's very precise, right? It's more precise than human beings. It's almost like, you know, human beings have 5 types. And if you belong to this type and you are this tall, you are this wide, you are 75 years old. And you will die in 8 years. It's that precise. It's that precise. Stellar mechanics stellar physics is fairly precise. It's fairly precise. Okay, so you can literally do. You can tell this kind of star. Looking at it right now, I can tell you when it was born and when it's going to die and how it's going to die. Right? It has a well-defined, and there's not much noisiness in this. Okay, you know why there's not much noise in it? Because stars are big. So it averages out all the funny noise within the thermonuclear process, right? So the rate of nuclear fusion in the star is almost like a clock, right? Everything is random, but once you have that many molecules to work with, you can say, right now, how many molecules just turn into iron, like that. It's that precise. Okay, so yeah, I like this idea of looking at something else besides consumer. I really love it. But I have to tell you that if there's a better science, machine learning doesn't stand a chance. There's only one exception to this. Anybody knows what that is? Where you have a precise science, but machine learning is better than precise science. You know what that is? Protein folding. Protein folding is a precise science, but it's so difficult to calculate. It's impossible to calculate that machine learning beats principle, beat analytical approach. That's the only place. It has to do with the complexity. Okay. It may be that in relativistic physics, general relativity, there are problems that are more difficult to calculate from real science, and you can use data science or machine learning to fill in the gaps. Okay? That happens from time to time. Like when I was doing finance, you have a well-defined surface of bond yield, but because it has different holes, instead of filling the holes with analytical formula, you can fill the hole with neural network. Occasionally, yeah, you can use that, but not here, not here. I think this is so precise. This is so precise, right? Okay, but I like where you're going. I just want to tell you that, yeah, if there's a real science, data science is not better. Okay, good. I like this. I like it.
All right, thank you.
Okay, Tirana, you're up.
Okay, let me share my screen. Okay, so I changed my project topic because the set of data isn't really there. So I changed to this one, which is more related to my project seed. So from my homework data, homework 5, I submit 2 set of data, but I look back and then I picked the set B. So in this set, the data, here's the data. It tells you the customer ID transaction, SKU, qualities, and sell amount. So my plan is that, like, since this set of data contain more information, I think there's a lot more to play around with. First of all, you can see the overall performance of the 6 period. Like, it allows us to optimize the operations and predict customer behaviors. So the things I think that I'm going to focus on is retail stock prediction from customer buying patterns. Since the data shows the period is 6 months, so we can say that in which month, which kind of SKU categories is
good.
Yeah, something like that. Yeah.
By the way, you don't know what these are, right? These are masks, these are areas, right? So you don't know so you don't know what these items are. So you can't tell whether or not X52 is similar to 1LF, right? This is all alias, right?
Yeah. But
is there a relationship that I can tell? Like, for example, this is all random number, right? Random alias, random names, right?
Yeah.
Okay.
But
you know what would be fun?
The categories and the items, which the item belongs to each category. So I think that it will be fine because
so you have,
if we look at the category, we can, we can show which one belongs to which one.
So you have how many products? Hold on. We'll go up a little bit. In the meta description, how many types? How many categories? What you can do, use this function counts. Do you know that? Count, C-O-U-N-T. Yeah, exactly. And it's going to tell you, okay, show that. So press enter, control enter. Oh, okay. And do the length of the count.
Okay. I can do it later.
Yeah. Length, big L. Yeah, length of the count, and that will tell you how many different unique product types and so forth. Okay. Okay, good.
Yeah.
So you're going to do like a lot of basket analysis type thing, yeah?
And I want to ask you that, so since here it tells qualities and sale amount, so like we know how many items people brought and how much their basket cost, should I focus on that one too? Like we can tell the potential customer and the repeated customer, because like I looked at the data and the customer ID, like sometimes it repeat themselves. So I think that means like customer come back on the
once you have
days.
this level of detail, the RFM, the recency, frequency, monetary value is trivial, right? It's trivial. It's a one-liner, literally, right? Okay. Yeah. So if, by the way, are you using data set object or?
What do you mean? Sorry.
Data set. Let me give you the link.
Okay.
Go look at the paper that I sent to your friend just now as well. That one uses example of data set quite a bit. But if you use data set, okay, if you use data set, let me show you, let me give you the link. Okay, what's your name? Jirana, right?
Yeah.
Okay, if you use data set, you can just say something like, you know, select group by customer and then select the latest date, and that will tell you the most recent. So that gives you recency already in one line. Okay, frequency, you can group by customer ID and then count number of transaction. So that gives you frequency, right? Monetary value, you do the same thing, except instead of doing the count, you use the word total or summary. So recency, frequency, monetary value, it's a one-liner in Mathematica. Okay, but it's better to put things in data set. That way you can do group by customer. And again, it's very important. If you go to the data set, go down on that page, there are options. You can see that at the bottom, you can do all kind of select in the group by. So another thing you can look at is group by. Group by.
You're sending it in the Zoom chat, right?
Yeah. So group by is to be used with data set. So let me send to you again in the line chat. Okay. Right. So you can do. So given data set, you can do something like data set group by, okay, group by say customer ID, say something like that, and then total, something like that. Okay, I total and something like total and apply to whatever purchase. Yeah, don't quote me exactly. I mean, I probably get something wrong. Okay, but basically what you do is you group by the customer ID and then you add the total purchase, and that becomes a total monetary value, something like that. Okay.
Okay. So this one is
sorry.
okay.
You know what?
Sure.
You know what?
Yeah.
I have been sending both to Jirana and Napatson to the wrong room.
So I was wondering which room you're sending it.
Okay, sorry. Okay. One moment. I was sending because I was talking to your TA earlier. Okay. Yeah. Sorry. Okay, share this, and share this, share to big data analytics. Okay, are you seeing this?
Yeah. So, thank you.
No wonder you're kind of suspiciously confused. Okay, it's going to look like that. You take the reference data set, you group by, so say what it pertains to. The function would be like total or minimum or maximum or select or something like that. And then you tell which column you want to apply it to. And you can do RFM in one line each. Okay, very good. Now, but you have a lot of information. Again, I don't want you to just get fixated on RFM. It's a very trivial analysis. If you have this information about, buying items, you can do a lot. And you can do more than even your friend, because your friend only have names of products. Now, your friend can mentally group between eggs and milks and alcohol versus cola and coffee and all that. But you actually have more information because your SKU has SKU groups, right? So you can do something like, instead of doing basket analysis of product level, you can do basket analysis of product groups, right? So maybe you have groups of products that tend to appear together, right? So maybe one group represents beverage, the other group represents party supplies or something like that, right? So you can do a lot of that. So you can do many levels.
The only problem is that even though I did the categorize by the categories, but like I don't know which category is which.
That's okay. That's too bad. That's what happened with Keiko. See, they want to give you real data, but at the same time, the insight, you can think of Keiko as, sometimes Keiko is like a public database. Sometimes a company, let's say I'm a company, right? I want people to do analysis for me. And the people who want to do analysis want the data so they can play with, like you want the data to play with. I want the result. So let's meet halfway. I give you the data, but I don't reveal the real name. You get the data, you play with it, you give me the result, and I use the result. So it's a win-win, right? It's a win-win. And this happens a lot with medical data. Okay? Because certainly medical data, I don't want to review my patient's ID, right? So who has cancer and who has whatever disease, right? But certainly, if somebody can help me analyze that, that's good for my patient. Okay, so this is normal fact of life. Okay, normal fact of life. So you just say that we find that category EX7 goes well with category 1, 2, 4. You don't know what that is. That's fine.
Okay.
I did exactly that, by the way, with my analysis of financial banking interconnectivities. I translate all the banks in Thailand into colors. And I do some kind of systemic network analysis, and I see which bank is more important to which bank, and I publish it publicly. Okay, but instead of saying, okay, this bank or that bank, I just say, ultramarine versus sunset blue or something like that. Okay, has nothing to do with real bank. Okay, that's fine.
Thank you.
Okay, very good. This is a good, exciting data set. Okay, let's go to Natari.
Hello,
Hello.
Screen.
Go.
Can you see my screen now?
Come on. Year birth, education.
Yeah, so it's...
And that looks familiar. Everybody's drinking wine data.
Yeah, I know. So I was thinking about changing it.
Yeah. Why not? It'd be boring.
Yeah, the next one I found is about the car.
Okay, let's go to car. Okay, so you drink and drive. Good.
Car one. So this one I'll compare if the car is overpriced or not by looking into the horsepower and the specification of the car price.
Okay.
But like I feel that the price also depends on the tax of the country. Like all different countries have different percentage of tax. So I don't know if it's a big concern or not.
No, it's not a big concern. You just have to take into account. So do you have this thing called CBU information? If it's locally assembled, it's actually not where it came from. It's whether or not it's outside the Kingdom of Thailand. Right? This is Thai data, right?
I don't think so.
Oh, you don't think so? Show me where the tax is.
Sure.
This from Keiko or something?
Yeah.
Okay. Car price. Look into the description. There should be some description. Car price data set. I would imagine that this came from the same market, no?
Yeah. Yeah.
It should be the same market. So the tax, it tax in turn should, you can't do discriminatory tax usually, okay? Maybe sometimes there's a special arrangement where, let's say, car produced in Mexico would have a lower tax than car produced in Germany because of NAFTA or something. But you know, that's kind of rare. Mexico doesn't produce car. So that shouldn't be a problem, okay? If there is, you just take into account for it. You can artificially, I was gonna say you can use the name brand to identify the country, but that's not true either. Because you have a lot, you know, imagine if this is American car market, you have Toyota made in North Carolina, right?
I see.
And you have Jeeps maybe made in Mexico. I don't know. So don't worry about it too much. Just whatever the data tells you.
Okay.
Okay. So the brand, okay. What you might do, if I may, okay, go back to your data set. They say car name, right?
Yes.
What you might do, you have car price here?
Don't think so. Oh yeah.
Yeah, you always have car price. You know, your car name has two information, by the way. It has the make and the model. Okay, so what you might want to do is actually create another column called the make. So it's make and model, right? So in that case, you can do comparison between makes. This is what data analysts call slice and dice. Okay, imagine that you have slice and dice is like, imagine you have a cube, okay? A cube of meat. You can slice it this way or you can dice it this way, okay? So slice and dice mean different perspective of comparison. So you compare, you can say, okay, I don't care what make it is. I'm just gonna look at, say, horsepower and whatever performance, but I'm not gonna care. On the other hand, you can say, all else being equal, let's compare just the brand name. Okay, so there's so it's not all X's. These are all X1, X2, X3, X4, X5, X6, but they have different meaning. Okay, for example, X that correspond to car body. Well, that's very generic, right? Every car has a body type. Okay, but then the car name has a Germanness or Italianness to it. Okay, so you can slice them that. So different, they definitely have different things, and this is quite interesting. So you can say, well, at the end of the day, you can analyze. By the way, this is not just machine learning. It could be done using like a regression. Okay, remember regression? I told you that you can make the squeezing function and make a classification at the output end.
Yeah.
Right? The input end, you can also do that. So you can have binary input or multiple class input. You can say 2-wheel drive, 4-wheel drive, or you can say foreign versus domestic. Okay, and you can use that kind of binary input as well. So it may turn out that the fact that it is a German car matters most, or the fact that it is convertible matters, you know, that sort of thing. Yeah, this is interesting. Okay, and certainly, please don't do the same drinking wine with teenagers or whatever, because somebody's doing that already. Okay, okay, that's good. That's good. Not Tari, right? Now, another thing I would add is maybe visualization, so you can do some kind of like options. All right, let's say I want to do cluster analysis, taking into account this set of factors, okay? Or alternatively, I want to do cluster analysis taking just the performance, just, okay? So you don't have to do one exercise, right? you have 10 different X's. Maybe 5 of them are interesting from one perspective. 7 of them are interesting from the other perspective. Okay, you can do all this. Now, if you're trying to do prediction, your objective is to add whatever variable makes the best prediction. So you throw everything at it. But if you're doing clustering or this kind of unsupervised learning, your perspective matters. You can say what matters to you. I care about car performance, colors, and body type. Okay? This is what unsupervised learning is a little bit funny, right? It's unsupervised, but you can dictate what you're looking at. Whereas supervised learning, you almost have no choice. You choose whatever X you have to make the best prediction model. Okay, that's your job. Okay, but with unsupervised learning, you can say, yeah, maybe being German or Japanese determines the car premium, but I don't care. I'm just looking at convertible. Okay, you can do that. Okay, good.
Thank you.
Wang Yan Feng.
Yeah.
Ooh, we're not going to cover everyone, so we're going to continue this exercise next week. So let's Wang Yan be the last guy.
Okay. Next.
Okay.
Let me share my screen.
Yes, please.
So
everybody's doing a good job, by the way. I'm not worried. If I'm worried from technical issue about whether or not you can formulate a prediction problem out of it, but yeah, you guys are all right. Okay, go.
Okay, so my data set is about body fat level. So I have a data set where it has the body fat level of 100 to 200 mens, and with a lot of other measurements. So I know that mostly body fat level are calculated by density only. So I was wondering, is there other way I can calculate body fat using other simple measurements? So I went on Google and I found out that there's different kind of equations. So I don't know which equation to use. So I want to try to predict an equation by the data myself. So I found out this data on Kaggle too. So this is my data set. So I'm using Python. So because I think it's easier for my data set. So yeah.
Yeah, I was going to suggest that, by the way, because I think what will be interesting is if you restrict yourself to decision tree type analysis, then you can start talking about interpreting, So good.
So right now I did some correlations between body fat and the measurements. Firstly, that we know body fat and density, I have a really high correlation. As you can see, it's a line, like a straight line over here. But for other measurements,
I don't think that is a correlation. I think that is a matter of fact. In other words, the two columns are not independent measure. You can imagine this, that one column is the divisor and the other column is the numerator or something like that. You have A is A and B, and then the other column you have A divided by B or something like that. And it turns out that B doesn't change a lot. So if B doesn't change a lot, column C is the same thing as column A. Sometimes you have to look at the unit and this is where how data is originated matters. Now, to make the problem interesting, you can say that body fat and density are virtually the same thing. So for this analysis, you're going to study body fat or density as a function of something else. But body fat versus density is not interesting because they're actually the same thing. They're just measuring in different units or something like that. You know what I mean?
Yeah, I get what you mean. So I went for other pictures for the circumference of neck, chest, and all this. Then I found out there's no direct link between the two rows, but there's some kind of link between each. So I did not do further analysis, but I think that I can form a formula or something in the future.
There is a concept, by the way, if you study regression, maybe in a more advanced class, called multicollinearity. That would mean something like the X, they don't vary independently, Well, in this case, the y's are not varying independently. So you just choose one y, okay? Just play with one y. Or you can do both. You can say, well, let's predict body fat, or alternatively predict density, okay? But definitely, yeah, those two are not, they are related. Not by, it's not coincidental. It just happens to be the same thing, I think. Good. Another thing I was going to suggest is this, by the way. Try what's called gradient boosting, okay? Now, the reason why I want you to try this is because gradient boosting tries to fit the best model from a smaller set of data and then add more variable to fit the noise. So you might see some kind of ordering. In other words, the model may choose for body fat prediction, they will go for the neck first. And once the neck variable is taken care of, it will incorporate the forearm or something like that. There might be a story there, okay? So this is where working with model that is a little bit more transparent, tree-based model, does give you a lot to play with, okay? So it's not just a prediction result, but how you get the prediction. It's a lot more interesting story to tell. Remember that last week I was showing you the decision tree, right? Well, that's what I mean. It's not just the ultimate prediction, but it's how you get there. Oh, the reason this person is more likely to have cancer is because the variability in the cell side. That's like the most important thing. And once that's taken care of, you look at other variables. So both decision tree and gradient boosting kind of has that flavor that, you know, what comes first? Okay? This is without going to do proper variable significant tests. This is actually just looking at the order of the algorithm. The algorithm choose the first thing first, neck circumference. So you can say, oh, neck circumference, that's a big deal. Okay. So yeah, it's good. I'm glad you're going the in this case the Python route, because it has that visualization of decision tree. Okay. Your data set is where again? From where?
Kaggle.
Kaggle. Okay. Okay, that's very good. I want you to go back, all of you, not just one, everybody who's using Kaggle data. I think you're skipping the description data part of the data a little bit. So a lot of you are just jumping to the data. Kaggle tend to have a good description or whatever they want to give you, okay? If they want to mask the alias of the product, they won't tell you. But they will tell you something like, oh, this is a data from supermarket in the Midwest or something like that, okay? I get a feeling that you haven't read the introduction page, the Kaggle, okay? Go back. I think there's a lot of information, okay? There's a lot of information that you're not looking at, okay? So it could be something like, it could be superficial, you know, just say something like car market in the United States. Fine, at least you know it's United States. It's not German car market, right? So I think you guys have not looked at the data description. So don't skip that, okay? Don't skip that, and be sure to reference it properly. Okay. Again, you have to be thankful of the data set they give you. Okay, Kap. That leaves me about 15 guys. Okay, so we might start with you guys next week. Okay, and again, I'll talk about the GNN thing and whatever we can fit in. Okay. Okay, Kap. No homework per se. From now on, I think just basically your project. Okay, your project. Now, here's the thing. Don't think of it as a fixed deadline. Okay, if you deliver the fixed deadline, I can only say, well, this is an A project, this is a B project, this is a C project, right? But if you deliver early and it's a B project, I can tell you how to make it an A project. Okay, so don't everybody just say, oh, I'm just going to hand it in mid-November. If you can hand it in next week, we can make it A project, right? And if it's that good, I can co-author with you and publish on paper with code. Okay, if it's that good. Okay, so don't think of it as, you know, big assignment. Okay, a project literally go at your own pace. Okay, and the earlier the better. Okay, I can guarantee you an A if you only gave me something like a B 2 weeks before it's due. I can guarantee you an A. See what I mean? Okay ครับผมระดา you have a question okay so okay ครับพี่นัทit's been grading your midterm as well so whenever things are ready I'll share it with you but again I like this kind of hands-on thing and you get a lot more direct feedback and because you know you guys are all friends right so you don't have to be shy if I criticize or if I see a gap in one project everybody benefits okay so this is the atmosphere that I cultivate in all my team okay be happy to show your vulnerable or your weakness so that everybody benefits from it okay this is not shaming there's no such this is community learning okay so good everybody's learning from everybody's project I like that okayครับ so I'll see you next Tuesday okay and I'll remember to use my telephone okayครับI'll see you guys good luck keep safe and take the vaccine shot whenever you can
thank you ค่ะอาจารย์ stay safe นะ
ดี
คะ
ครับสวัสดีครับ
thank you ครับครับบ๊ายบายครับ
thank you ค่ะ
thank you ครับ
thank you ค่ะอาจารย์